Hello, in this lecture we will find the size of 2 times AP, or the value of 2 times AP. In the drawing we have triangle ABC. Side AC of the triangle is 70 units. Side BC of the triangle is 50 units, and side AB of triangle ABC is 90 units. We have also circle in the drawing that its center is in point C. The center of the circle is in point C, and point C is on side AB of the triangle. Okay, so and also side AC of the triangle is tangent to the circle at point that we will call that point O. Okay, and so the side AC of the circle is tangent side AC of the triangle is tangent to the circle at point O, and also side BC of the triangle is tangent to the circle at side that we will call this side at point that we will call this point point E. Again, side BC of the triangle is tangent to the circle at point E. Okay. We will connect points C and P by a straight line. Okay, points P and C are connected with a straight line, and we also connect points O and P with a straight line. So points O and P are connected with a straight line, and as you can see from the drawing, line OP is the radius of the circle because it exits from point P and touches to the circle. So actually OP, line OP, is the radius of the circle. We will call OPR. R is abbreviation for the radius. Okay, line AP is the radius of the circle, and in the same way we will connect points E and P by a straight line. Okay, points P and E are connected by a straight line, and actually line EP, from the same reason, is the radius of the circle, so we will mark it as R. Because it starts from point P, that is the center of the circle, until it touches the circle at point E, so it is the radius of the circle. Okay, so we have here two radiuses of the circle that of course equal to each other, but actually according to, we have a rule that if you have a circle and from external point of the circle, let's call it V, from point V, external point of a circle is a point that is not inside the circle nor on the circle, but it is outside the circle. So it is called external point of a circle. So from point V, we will draw two tangents to the circle. This will be the first tangent, and this will be the second tangent. Let's call the touching point of this tangent with the circle L, and let's call the touching point of the tangent of this tangent with the circle F. So according to the rule, those two tangents are equal to each other. So VF equals to VL. Okay? Okay, VF equals to VL. So whenever you have external point of any circle, and from that external point you draw two tangents to the circle, then those tangents are equal to each other. Okay? This is the rule that you should know. So it is relevant, this rule, to our original drawing, because we have external point, that is point C of the circle. C is external point of this circle because C is not inside the circle nor on the circle, so it is considered as external point to the circle, and we actually have here two tangents to the circle from point C. This is the first tangent and this is the second tangent. So according to our rule, we can say that CO equals to CE. Okay, so we can write that CO, the first tangent, equals to the second tangent. Why? Because of the rule that whenever you draw two tangents from external point of a circle, then they are equal to each other. Okay, so CO equals to CE. Okay, but as I have already told you, PO also equals to PE equals to R. PO equals to PE equals to R, because both of those lines are the radiuses of the circle, so they are equal to each other. And also PC equals to itself. So we can write it down. First of all, PO equals to PE equals to the radius of the circle. And CP or PC, it is the same, equals to itself. Okay, again, CO equals to CE according to the rule that I mentioned, that if you have external point of a circle and from that external point you draw two tangents, then they are equal to each other. So for this reason CO equals to CE, and also PO equals to PE because both of them are radiuses of the circle, and PC equals to itself. So actually we have here triangle. So the triangle that I painted in the green color actually is congruent to the black triangle, or the green triangle congruent to the black triangle, or the green triangle is overlap the black triangle. So I will write it down. Triangle COP congruent or overlap. So that is to say the green triangle congruent to the black triangle. That is to say CEP. Okay, the green triangle overlap the black triangle, and I will explain why. Because three sides of the green triangle are equal to three sides of the black triangle. CO of the green triangle equals to CE of the black triangle. PO of the green triangle equals to PE of the black triangle, and PC of the green triangle equals to PC of the black triangle. So we have three sides in the green triangle that are equal to three sides of the black triangle. Therefore, those two triangles can go end to each other, or those two triangles overlap each other. Okay, the triangle COP, the green triangle, is congruent to triangle CEP, the black triangle. Okay, so we can deduce from the fact that those two triangles congruent to each other that this angle PCO, equals to angle PCE. Again, angle. Therefore, angle PCO equals to angle PCE. Okay, because of the fact that the green triangle congruent to the black triangle, we can deduce from it that angle PCO equals to angle PCE. Write it again. Angle P. Okay. Angle PCO equals to angle PCE. Okay, angle PCO equals to angle PCE. Angle PCO equals to angle PCE. According to the rule that corresponding angles in congruent triangles are equal to each other. Again, corresponding angles. Angle PCO corresponds to angle PCE. Corresponding angles in congruent triangles. The green triangle congruent to the black triangle, so corresponding angles in congruent triangles are equal to each other. Okay, for this reason angle PCO equals to angle PCE. Okay, so in the next step I will draw again triangle ABC. So if we call angle PCO theta, then angle PCE also be angle theta, because those two angles are equal to each other. Okay, so we will call angle PCO theta, so angle PCE also will be called theta. Okay, or you can see it as angle PCA that is theta are equal to angle PCB that is also theta, because those two angles are equal to each other. Okay, again we will call angle PCA theta, so angle PCB also will be called theta. So I draw again the triangle ABC. This side equals to 70 units, this side equals to 50 units, and this side equals to 90 units. And P is the center of the circle, and actually, according to angle bisector theorem, okay, write it down. According to angle bisector theorem, first of all, as you can see in the picture, we have 9CP that is called angle bisector. Why? Because it divides angle ACB to two equal parts. For that reason, CP in the line in the red color is called angle bisector. Okay, so in triangle ABC, we have angle bisector CP. Why it is angle bisector? Because it divides angle ACB to two equal parts. This angle is theta, this angle is also theta, so it divided angle ACB to two equal parts. So CP is angle bisector in triangle ABC. So the angle bisector theorem states that an angle bisector, that is to say CP, in a triangle, that is to say triangle ABC in this particular case, but it is true for all the triangles in the world. An angle bisector in a triangle divides the side that it is as you can see here, angle bisector CP eats side AB of the triangle. Okay, it states that it divides this side AB to two parts, that it's actually it divides it in a ratio that equals to the ratio of the angles sides. So actually the angle bisector theorem states that this angle bisector CP divides the side that it is, that is to say angle bisector CP its side AB and it divides it to two parts, and the ratio between those two parts, that is to say AP over PB, the ratio that it divides side AB, AP is AP over PB, okay? It divides side AB to two parts, AP and PB, and the ratio between those two sides, that is to say AP over PB, equals to the ratio of the angle sides. We are talking about the angle that is divided to two equal parts, and the angle that is divided to two equal parts is angle ACB, and angle ACB consists of two sides, AC, side AC and side CB. So the ratio between those two sides, that is to say AC over CB, equals to the ratio that CB divides AB, that is to say AP over PB. Okay? Okay? The ratio that angle CP divides side AB, that is to say AP over PB, equals to the ratio of the angle that is divided, the sides of the angle that is divided to two equal parts. This angle is actually angle ACB, is divided to two equal parts, and the sides of ACB consist of side AC and side CB. So the ratio between the sides of ACB is AC over CB. So AC over CB equals to the ratio that CP divides AB, that is to say AP over PB. Okay, so again I will repeat again on the angle bisector theorem. An angle bisector theorem states that an angle bisector in a triangle divides the side that it is in a ratio that equals to the ratio of the angle's sides. Okay, so again I will repeat again on the explanation. In our particular case, we have triangle ABC, and in this triangle we have actually an angle bisector that is PC. Why PC is angle bisector? Because it divides angle ACB to two equal parts. This angle is theta, and this angle is also theta. So PC divides angle ACB to two equal parts. For that reason, PC is angle bisector in triangle ABC. Okay, so the theorem states that an angle bisector in a triangle, in this particular case, triangle ABC, divides the side that it eats, the angle bisector PC eats side AB of triangle ABC, and it divides it to two parts. And the ratio between those two parts, that is to say AP over PB, equals to the ratio of the angle sides. The ratio between the angle sides is AC over CB. So the ratio AC over CB equals to the ratio of AP over PB. Okay? So I will repeat again on the explanation. An angle bisector in our example is CP is angle bisector in a triangle ABC, divides the side that it eats, it divides side AB, and it divides it to two parts, and the ratio between those two parts is AP over PB, and this ratio equals to the ratio of the angle's sides, in which we relate to angle that is divided to two equal parts, and this angle is called ACB. And the ratio between the angle sides is AC over CB, because angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. So this ratio equals to the ratio between AP over PB. Okay, or AP over PB, the ratio that the angle bisector CP divides side AB of the triangle equals to the ratio of the sides of the angle that is divided to two equal parts, and this angle is angle ACB, and the ratio between its sides is AC over CB. So this ratio equals to the ratio of the CP that divides side AB. That is to say AP over PB. Okay? An angle bisector CP in triangle ABC divides the side that it eats, divides side AB to two sides, AP and PB, and the ratio between those two sides, that is to say AP over PB, equals to the ratio of the angle sides. And the angle sides, this angle sides is AC over CB. So the ratio between AP to PB or AP over PB equals to the ratio between AC over CB. So AP over PB equals to AC over CB. Okay? So we can define that AP equals to X, AP equals to X, then PB will be AB minus AP, that is to say 90 minus X, because it is AB minus AP, it is PB. So we can write again the equation that is derived from angle bisector theorem. We will mark it as equation 1. Equation 1 says that AP over PB equals to AC over CB. Okay? But we defined AP by X. AP equals to X, yes? AP equals to X and PB equals to 90 minus X. So in this equation we can substitute AP by X and PB by 90 minus X. Okay? AP equals to X, so we can substitute AP by X, and PB equals to 90 minus 6, so we can substitute PB by 90 minus 6. So we will get that X over 90 minus 6 equals to AC over CB. So we substituted AP by X because AP equals to X, and PB by 90 minus 6 because PB equals to 90 minus 6. Here we know that AC equals to 70 units and CB equals to 50 units. So write it here. AC equals to 70 units and CB equals to 50 units. So we can substitute AC by 70 and CB by 50. Okay, so X over 90 minus 6 equals to AC equals to 70 over CB equals to 50. Okay, here we substituted AC by 70 and CB by 50, and also 70 equals to 7 times 10 and 50 equals to 5 times 10. I will write it here. Okay, so X over 90 minus 6 equals to 7 times 10 over 5 times 10. Here X over 90 minus 6 equals to 70. Instead of 70 we wrote 7 times 10, and instead of 50 we wrote 5 times 10. So we have 10 in the numerator and we have 10 in the denominator, so we can cancel 10, or we can reduce the numerator and the denominator by 10. So we will get that x over 90 minus 6 equals to 7 over 5. We cancel 10 from the numerator and from the denominator. So we got 7 over 5. Here we can multiply both sides of the equation by 5. We'll get that 5 times x equals to 7 times 90 minus 6. Okay, here we multiply both sides of the equation by 5. Here x over 90 minus 6 multiplied by 5 equals to 1 minute please. So we multiply both sides of the equation by 5, so x over 90 minus 6 equals to 5x over 90 minus 6, and 7 divided by 5 times 5 equals to 7. Now we will multiply both sides of the equation by 90 minus 6. It is allowable to multiply the equation by 90 minus 6 because as you can see from the drawing, x equals to AP and x is less than 90 because 90 is all the side of AB, so x is less than 90, so 90 minus 6 must be positive number. So 90 minus x can never be 0, so we can multiply both sides of the equation by 90 minus 6, okay? So we will get that 5x equals to 7 times 90 minus 6. Okay, we multiplied both sides of the equation by 90 minus 6. 7 times 90 minus 6 equals to 7 times 90 minus 6, and 5x divided by 90 minus 6 times 90 minus 6 equals to 5x. Now we will open the brackets. We get that 5x equals to 630 minus 7x. Okay, here we open the brackets. So 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Now we will add 7x to both sides of the equation. We will get that 5x plus 7x equals to 12x. So we added 7x to both sides of the equation, so 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we divide both sides of the equation by 6. We will get that 2x equals to 105. So we divided both sides of the equation by 6. So 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. Now we define x as AP, so x equals to AP. According to our definition, x equals to AP. Okay, x equals to AP, so 2 times 6 equals to 2 times AP. So 2 times x equals to 105, and 2 times 6 equals also to 2 times of AP. So we can write again the first equation. Get 2 times x equals to 105, but 2 times x equals also to 2 times AP, so we can write here that 2 times x equals also to 2 times AP. Okay. Okay. Again, 2 times x equals to 105, but 2 times x equals 2 times x equals also to 2 times AP, so we can add the 2 times x equals to 2 times AP, or here is written that 2 times AP equals to 105. Okay, so two times AP equals to 105. Actually, that was the equation. We wanted to find the size of 2 times AP. Okay. So 2 times AP equals to 105, and that was the question. We wanted to find the value of 2 times AP, and we found out that the value of 2 times AP is 105 units. Okay, so I will summarize the lecture. So actually the question was to find the value of 2 times AP, and we have here a triangle that the size of AC is 70 units, the size of BC is 50 units, and the size of AB is 90 units, and we have a circle that the center of the circle is P, and the point P is on side AB of the triangle. So we actually created 2 triangles, the green triangle and the black triangle, and those 2 triangles are congruent to each other or overlap each other. For that reason, this angle equals to this angle, or angle PCO equals to angle PCE, according to the rule that corresponding angles in congruent triangles are equal to each other. So we draw again the triangle ABC, and actually here PC is angle bisector because it divides angle ACB to two equal parts. This is theta and this is also theta. So the angle bisector, according to angle bisector theorem, the angle bisector PC divides side AB in triangle ABC to two parts, and the ratio between those two parts, that is to say AP over PB, equals to the ratio between the angles sides, between the angle that is divided to two equal parts, between the sides of those two angles. So the ratio between the sides of angle ACB is AC over CB. So AC over CB equals to AP over PB. And we created from this equation, we called AP X, and so PB equals to 90 minus 6. And we actually created very simple equation from the angle bisector theorem. We called APX and PB 90 minus 6, so x over 90 minus 6 equals to AC over CB, but we know that AC equals to 70 units and CB equals to 50 units. So we can substitute AC by 70 and CB by 50. So we got that x over 90 minus 6 equals to 70 over 50. And it is one equation with one variable. So at the end we got that 2 times AP equals to 105 units. Okay? Thank you very much.